Three.
Hey Mohan, how are you?
Hi, Kent. Great. How are you doing today?
I'm doing good. I'm doing good. So we're back. We're doing session two, right? Session
Yes.
two, and we're going to cover two topics today. We're going to cover file system layouts, and we're going to cover some instance configuration best practices, right?
Correct. Yes.
And and the subject, the overall subject that we're covering is DSFA. You know what that stands for? You remember?
Oh, yeah. So database services, flexible architecture, and it like TOGAF, right? So where people using TOGAF framework to implement global enterprise architecture, I think this is kind of enterprise level architecture for databases alone.
Yeah, and we kind of talked about last time, that if you're just building laptop or, small office, back office kinds of environments or systems, you don't really need a rigid, strong architecture because the workload is low and you can probably shut it down anytime you want to and bring it back up.
Yeah,
But this is for enterprise level, right? This is for
exactly.
the large scale environments with thousands of users and, high availability requirements and significant impact to the business if these systems are down and for any reason, right? So we kind of want to present a roadmap for building out the environment, and we're going to start from the outer layer being the server, and then we're going to talk about the file system layouts because you've got to basically get your file systems configured and laid out, set
Mhm.
up, maybe using a Unix administrator or on a mainframe person to help you set up the file systems, or on a Windows platform, helping you get those all configured and set up. And and then we're going to go to the instance, and then on later sessions we'll go down into the database and maybe some SQL best practices and some other things from a client perspective, right? Because I think there's an important thing here that we need to say that we probably didn't talk about in the opening session. That's another reason for listening to all the sessions, because I don't know about everybody else that does videos and does this type of content, but as soon as you turn off the video and you stop, there are two or three things you wish you had said and you forgot to say them, right? So we can cover certain things that may be off topic a little bit in each of these sections. By listening to all of them, it would be good. When you're building a highly available continuous operational environment, you can't just build the database that way, right? You also have to um, build the applications or the products that are going to interface with this database. They have to be configured also in a resilient, highly available manner, right? As
Right.
an example, if for some reason they can't connect to the database, they can't just give up, right? They
Yes.
can't just stop running, because if they did, then you'd have to basically reboot them all, restart them in WAS or Tomcat or JBoss or whatever, or if you Spring Boot, you may have to stop them and restart them to get them to reconnect. So you got to have some resilience in the client. And one of the things we implemented not too long ago, right, was the application name on the actual URL for the connection, and it helps us to identify the exact workload, whether it's a service workload or an application or a product workload. It helps us identify the workload that's connected to the database specifically, because you may have an application that may have 40 or 50 services, and if you don't define that client right, then you may have a difficult time trying to figure out which service is actually involved in that connection failure. So
That's right.
yeah. All right, so back to file systems. Sorry about that, I got kind of off base
No, that
here.
was awesome. That was great.
But so you know I'm showing a part of our book, Mohan and I, and my book. We're in Appendix A of that book, and there's a section on file system management, right? And we're going to talk through some of this in better detail than what we actually provided in the book, which we didn't leave out too much detail, but we did had to leave out some things. So on the screen right now, you see performance scale. Performance scale is the impact to the overall system or application if that particular type was to have some I/O performance issues. So you can see that we've got them defined by software and support, metadata, user data and indexes, system and user temporary tables, active logs, and archive and historical logs. and you see that they're each given a scale number, with active logs being the highest impact, right? And then there's a note down there that says if it's a read-only database, then the active logs are less of a impact for just a read-only database. But for the most part, you're going to run a mixture of 40, 60 or 30, 70 reads to writes, something of that nature. Whether they be write heavy or be read heavy. If it's write heavy, the active logs are extremely important to the performance of the overall system, right? But so you see here, we got software for the binaries, the OS binaries, the DB2 binaries that are deployed in opt-IBM and to the local instance owner location with soft links and some binaries as well when you create the instance. And we'll talk about that in just a few minutes. We've got the support files systems, the directories file systems, and just the normal support stuff where you write logs and you do certain things for scripts and processing and things like that you run. You got the metadata. We put our syscat space in a completely different location than we do our user data, right? They're separated out. Our user and data index and data pages are in separate locations as well. And then of course we put temporary, which is SMS, right? We put temporary SMSs in their own storage area as well. And then we have active and archive logs that are separated out as well. So these are the important file system areas specific to DB2. So let's talk about each one of them and how they operate and function, right? So as probably most people know, right, DB2 and systems in general have many different types of IO patterns that they execute against the files. So, you've got concurrent IO, direct IO, you've got sequential, asynchronous, you've got prefetch, limits and levels, which are, consecutive pages that are loaded in for one IO, right? And then you've got different page sizes, right? In DB2, we have, 4K pages, 8K pages, 16K pages, and 32K pages. And the IO time for those pages will be different because of the amount of data that's returned for each page. For RAID devices, you also have, RAID 0, RAID 1. I think it's all the way up now to RAID 9, maybe. I can't remember exactly, but the pertinent RAIDs that we see today are RAID 0, RAID 1, and RAID 5. Those are the RAIDs that we see, and I think RAID 6 is actually pretty common now as well. But 0 is striped, 1 is mirrored, and 5 is a parity bit page written. It's write tolerant for failure, and it's striped. So it used to have a write penalty, but that's since been eliminated with modern disk storage. The penalty really isn't much at all for a RAID 5 device anymore. So we run in one of our shops that me and Mohan work at. We run different DBMSs. We run Oracle, we run SQL Server, we run DB2. One of the things that DSFA stresses is to try to get all of them on the same type of file system layout. So Oracle and DB2 are very similar. And so you can have a file system pattern that is pretty much consistent across them. And that's really important if your DBAs float, if they work Oracle issues, if they work DB2 issues, and if they're one common group of DBAs that to support both of them. It's not as critical, I guess, if your mid-tier DBA group is isolated. If DB2 is a different manager, a different group than your Oracle group. But it's really important if they share and they work across different platforms and environments, because it's common. So it's easy for them to move and navigate find log files, find messaging files, be able to go look at the, by doing DF commands, just see what the allocations and layouts are, and quickly get that information. They don't have to go back to some book or manual if they haven't looked at Oracle for 6 months or 3 months, and they don't have to kind of reacquaint themselves with the layouts. So we have some support areas, right? The home is the instance home, or the Unix home for the DB2 instance. And again, we'll talk about the instance in just a few minutes. But that's where SQLib is, and is where the home for the DB2 account is, right? And then we have an admin directory file system. Technically, it's a file system. And underneath admin, we divide up our support files based on their type. So we have data, temp, log, config. We have Java. We have the compiled Java classes. We also have SQL. We have what else? We have SQL. We have data. I think that's it. I think SQL.
Admin.
Yeah, we have admin, and we have scripts, and we have SQL, and we separate them out, right? So config is where we store configuration files. Like, for example, if we were to run the deprecated DB2 governor, right? You have a config file for the governor. That config file would be in there. Other places we have config files, or we also have a table space monitoring process that runs, and it has a configuration file, and we place a configuration file there for the databases that it's monitoring. But we place our config files there, right? And then for Java, we think it's important as DBAs to understand the languages that most of our clients and customers write in. So that most of our customers are developers, right? And so they use Java. So it's pretty important that we know Java, at least to being able to read it and understand it. It doesn't mean that we're great Java developers, but it does mean that we understand it and can read it. So we'll do things like run stats with Java. We'll do certain business processes or functions that are specific to the database. We may even write some Java functions or Java stored procedures and use those instead of using SQL. And it helps us to be able to address issues that our developers see. So we have a Java library. The log library is for script processing, right? So all of our scripts, especially our monitoring scripts, they log, and we evaluate and check those logs for execution. And then temp is what it sounds like. It's just temp files. They get deleted, destroyed. That, matter of fact, the contents of that temp folder could be wiped out at any time, and it wouldn't hurt anything. Data is where we would store probably mostly property file type data, because it's not really a big area. The admin file system is not that gigantic. It might be 5 gig, maybe 10 gig. So it's not that large. We have an EXP file system that might be, it will be large enough to be able to store the largest schema that we run in any database. And that's where we would unload schemas, zip them up, FTP them, reload them back in again. If we're reorging or something, we might unload and reload back instead of running the reorg command for some tables. And that file system is right here. You see it where my cursor is. It's EXP file system. We use TS temp as our temp storage location, the SMS table spaces that make up your system temp. And then we use TS and then a number. That number can be from 01 through 99. And we use that for data and index table spaces. And so our system table space, which is in its own table space, is usually going to be in TS 01 file system. But again, today with automatic table spaces and all of that, with UTF-8 and the configurations that we have for, I think what was that, like from 9.7 forward, right? Somewhere in that ballpark, where we use automatic table spaces. We lay them out usually across all of them. Now we will allocate user and index table space allocations based on the number of cores on a system. And there's a long history behind this, but it has to do with the number of service processes that are running, whether that be read or write services that are started, you know, the num processes that are configured to run at the database level, but also the number of cores, right? So if we have 6 cores, for example, we would create 5, so TS 01 through 5. If we had 16 cores, we might do 01 through 15 file systems, because that will allow us to stripe the data and to partition the data and allow for a degree of IO parallelism that we're looking for across all the different files. When we have really large structures, like over 1 million rows in a table or something of that nature. So the number of TSs that we allocate, both for temp as well as for user and user data and user indexes, will vary based on the size of the server and the number of containers that we create per table space. So we'll try to stripe them. The other thing we'll do, and this goes back to a history of SAN technologies, whether it be Proctier or any other intelligent network SAN device you have connected to. Being an old guy, I don't believe that the system does a better job than the DBA. So I don't leave the performance of the IO up to the SAN and just say I can put it anywhere in the SAN I want to and performance is going to be wonderful. We've seen and been able to document cases in which that's not true. So what we will do with containers, especially for tables that we unload and reload on a regular basis, is we'll take the data and we'll load the data 01 through N, which is the number of file systems we have defined for user and data, indexes and data. And we will, like, let's just say it's 01 through 4. Then we would go 01 through 4, first container being 01, last container being 04. And then for the indexes, we would go 04 to 01. So we go in exactly the opposite direction. So we go 04, 03, 02, 01 for all the index containers. And we would do 01, 02, 03, and 04 for the data containers. Yes, that's kind of weird, maybe for some people to hear, but for us, it's important. The other thing too here is a conversation a little bit about PureScale, and the last two down here, we're talking about the instance share. That's the DB2SD that you see down here, and the tiebreaker. Right, the tiebreaker disk. There's actually, what people don't know, Mohan, there's actually 2 tiebreakers, right? There's a tiebreaker for PureScale, and there's also a tiebreaker for the SAN
for the file system, yeah. So
for the shared file system in the SAN architecture,
right? We look at about a 1 gig for outing purpose.
Yeah, yep. So you really have 2. Now, again, for regards to PureScale, there's only 1, right? But for the GPFS file system, there's a second tiebreaker that exists. But these are the instance share. We talk a little bit about RAID here, right? So let's talk about a little bit about RAID. Really, the active logs and the archive logs, they really don't benefit from a RAID 5 situation. They really don't benefit from that. They do, and they really don't benefit from striping either. So if you could do just RAID 0 for your active logs and your archive logs, that would be fine, right? I mean, if you wanted to mirror them, you could, but again, most systems, we don't do that for most of them. For RAID 5 is where you're going to do that for your user data and index table spaces. You're going to define them with RAID 5. Again, RAID 5 doesn't do a whole lot of good for your temps, right? Because again, a failure of any kind is going to just result in the transaction failure. You don't retain any data that's stored in temp. So there's really not a whole lot of benefit in temps being RAID 5 either. You also have a large set of them. So you may have 01 through 09 depending on how many sorts and things like that that you have executing in your system, you could have 10 or 15 temps, and there's really no need in doing that. Another thing too, if you're using storage replication like SVC3 global mirroring, technically there's no reason to global mirror TS temp, because there's nothing there for you to replicate that's going to get used on a restart. So there's no need in replicating that using SVC3 global mirroring. So you'd want those allocations to be on disks that are not behind the SVC, because that's how global mirroring actually works. Is it's the SVC is actually mirroring and processing those disks that are behind it in a replication set. And then of course we have this area called overflow, which I really think is important, especially if you're actively involved in restoring databases, right? Because when you bring those logs back, right, Mohan, you want to put them, you don't want to put them in active, you don't want to put them in archive, you want to put them outside of that. So you put them in the overflow area and then complete your restore, and then you can either remove them or leave them when you're done, right? That way you don't have to deal with your active and archive logs, right?
That's right. And then if at all we need to extract few transaction logs using DB2 ADUTIL, you can specify this file system and then get those transaction logs back into your server.
Yeah, you could, and that will actually go out to your TMS storage area, right? And we'll recall all of those in one execution, right?
Correct.
It'll go back
TSM,
and get
right.
all of the logs that are necessary, right?
Yep.
That way, that'll speed up that whole recovery process, so you won't be waiting on logs to be recalled, right?
Exactly.
All right, so I think that's, did I miss anything, Mohan, on file systems? You think that's
no, that's we covered everything. I think that's a nice job of covering. Thanks, Kent.
All right, so you want to talk about instance?
Yes, of course.
All right. So one of the things I think we said in the server setup was don't create the instance as part of your install. Don't run DB2 setup and create the instance. Go ahead and run DB2 setup, deploy the binaries, get your software all deployed and set up properly, and then come back and create your instance using DB2 ICRT. And we still recommend that. We believe that's the right way to go about doing it, right? Now we have our accounts defined locally on the server. We think that's the right thing to do, because if you've got some AD disruptions or an LDAP disruption, then obviously that would be bad. If that account is remotely authenticated, you'd have a service disruption in that case. But if you've got it local to the server, the chances of you having some form of disruption there is very, very, very low. I mean, the server may crash, but that's a totally different issue. So we use DB2 for our accounts. One of the things I would stress, especially in this world of cybersecurity and things that are happening often in our world, is don't use defaults. Don't use DB2 inst 1. It's in every book. It's in every example. It's publicized all over the place. Don't use it. If a hacker is trying to find DB2, that's the first place they're going to go. And don't use the default ports. Use a port definition that they'd have to do a little work to find. The other thing you want to do on your server sides, and I think we did talk about this, is you want to be sure you're using blocking on your network so that you zone your networks, prod, dev, and you don't let anything inside that zone. And you make sure that your DMZ is built for anything coming from outside that zone in, and you close off all ports that you don't need open. In other words, when you build these servers, you build them with block by default on all the ports, and then you open them up only the ports that you need. And that probably provides you the highest level of security possible, at least from a penetration perspective. So we define all of our DB2 instance accounts with the letters DB2, and then we follow that by an application prefix that tells us a little bit about what that instance was built for. In our case, we use DSG to stand for data sharing group. So when we set up PureScale, we set up PureScale with DSG because it's a cluster technology. If we were to purchase SAP products, for example, that run in a DB2 system, we would use SAP. Same thing's true for sometimes people will use PRD for production. We think that's invalid and shouldn't be followed. You should, if you're going to create a private instance, then you want to use a name that's specific for the private use of that instance, what's actually running in there. And you shouldn't use version levels either, right, Mohan? Because as soon as you upgrade, if you're using 10.5 and you upgrade to 11, then you got a DB2 instance that's 10.5. That doesn't make much sense, does it? Probably bad examples to use. What else on the instance? I can't think of anything else on an instance create. Now, there is one thing, and it's not even in our discussion of this section. So Mohan and I, we actually have a configurator that validates the configuration once the instance is created. So we can go and we can create one of the members of our team members can go create an instance. And then when they create that instance, they run this configuration verifier that will identify any non-best practice configuration setting that was implemented within that instance. We highly recommend that you do that you build a verification process, not only for your instance, but also for your database, which we'll talk later about. And that way, no matter what team member builds it, they run the verifier, they get the report, and that verifies that it was built correctly. We also have in our enterprise a verification process. I won't tell you the name of it, but basically it's a verification process that runs, and it goes and it probably runs once a quarter, and it goes through all of the instances and all the databases, and then identifies any security issue or any configuration issue that we deem as being unacceptable in our environments. And we then assign DBA to go fix those and remedy them. So not only do we check whenever we create one, but we also check periodically throughout the year to verify that no one's made a change that would violate that. So I think that about covers it, Mohan. Anything else you think?
That was a great coverage. Thanks, Kent. Yeah, thank you very much. And then we'll come back again in the next session.
And we're going to do databases, right?
Databases, yeah.
I think databases is the next one. And then I think that pretty much does it. Now, database is going to be a significantly lengthy one where we're going to cover all aspects of database, and we'll even talk about client configurations as well.
Yes.
Yep. Thanks, Mohan.
Awesome.
This has been fun, man.
Thank you. So we'll touch base again.
Yep.